Okay, the next type of compound we're going to look at, you don't need to worry too much about it in detail, but I'll just explain quickly how it works, and then it's not something you're probably ever going to get tested on at year 9, but it's worth having a quick look at it just so that you understand what happens basically when we get two non-metals together. So these are non-metals joining. Okay, so we'll go back to our classic non-metal that we like to look at, which is H2O. So this one is a molecular compound. So we've got hydrogen and oxygen, both non-metals, okay, and these are going to join together. Now, these don't join in the same way, so they don't have ionic bonding, so they don't have ions, they don't have two charges that are going to help them stick together. What these will do is try to share their electrons. So if we think about hydrogen, first of all, that's nice and easy. We've got one electron, and over here we've got oxygen. If we look on our periodic table, it's got 8 electrons. Okay, so if we think about drawing these, it's probably going to be the easiest way to do it. Okay, so we've got one hydrogen here, and we've got 2 oxygens over here. So hydrogen's nice and easy. Oh, so they're nice and easy. Okay, so they've got 1 electron each on their outside shell. Now oxygen is a bit more tricky because we've got 8. So on the first shell we're going to have 2 electrons. We have to have a second shell here. And this one is going to have 6 electrons on there. Like that. Okay, now what they do is these little atoms will snuggle up to each other, and they will actually try to share an electron. So this little hydrogen here will snuggle right up here to this oxygen, and it will share electrons. So we get those 2 there. Okay. This little hydrogen will also come over here, and it will join up here, and it will bring its electron with it, like that. So what we've ended up with is the hydrogen now has got 2 on its outside shell if we go around that circle. This hydrogen's got 2 if it goes around this circle, so they're both happy because their outside shell is full. And our oxygen atom has got 2 on its inside shell, and then on the outside shell we've got 1, 2, 3, 4, 5, 6, 7, 8. So it's also happy. So non-metals, when they join, will actually share electrons. Okay. Now, like I said, you don't need to go into a lot of detail about that in year 9, but in year 10 you will go into a lot of detail about this. But still, when we look at this, it still is telling us the ratio of the atoms that we have here. So water, 2 hydrogen, 1 oxygen. If we look at carbon dioxide, 1 carbon, 2 oxygens. If we looked at something like ammonia, 1 nitrogen, 3 hydrogens. Okay. The key to knowing whether it's a molecular formula or not, a molecular compound or not, is looking at the elements that you've got and saying, are they metals or non-metals? Okay. If you've got a metal and a non-metal, it must be an ionic compound. If you've got 2 non-metals, it must be a molecular compound. Okay, so that's what you're going to be looking for when you're trying to spot, is it molecular or is it ionic? Okay, so if we had something like magnesium oxide, metal, non-metal, must be ionic. Okay, if we had sulfuric acid, H2SO4, we've got hydrogen, we've got sulfur, we've got oxygen, all non-metals, so it must be molecular. Okay, there are some more of these that you can practice on page 15 in your notes if you haven't already. Okay, so basically you need to make sure that you know what things are metals, what things are non-metals, especially from those top 20. Okay, but remember there are some other non-metal, there are some other metals that we've asked you to have a look at as well on the first few pages of your notes. Okay. So ionic or molecular, we call them all molecules. Okay, they're all joined together. Molecules, they are compounds. Okay, but they are not all molecular compounds. Some of them are ionic compounds.